Hello everyone, welcome to my channel today. So today our study is going to be on logarithmic functions. Specifically, we are going to talk about the natural logs, okay? Now I have a diagram here for all of us. We're going to talk about it. So the diagram in blue with this particular green, right? Well, yeah, we can see green. I'm colorblind, so excuse me about that. This particular curve is what we call the exponential curve, okay? The exponential curve. All right. Now, when you reflect this curve in the line y equals x, you will get this particular one called the curve of ln x, okay? Ln x, or the natural log of x. Now, what are we talking about? Well, in nature, you come across exponential functions, okay? Now, the most popular one that you would say is e to the power x is the basic that you will see. Now, e is a number. So, a function like e to the power x could also have a similar function like 2 to the power x or 10 to the power x. They are all exponential functions. They are all going to behave like this, okay? Now, normally, if it is 2 to the power, let's say you have 2 to the power x is equal to 10, and you want to solve for the value of x, you take the log of both sides and then you solve. So you are going to get x is equal to log 10 over log 2, okay? And then, you can just put it on a calculator, you know what to do. Now, the problem comes in when you have e to the power x, let's say e to the power x is equal to 3, okay? So, of course, you may say that, well, let's take the log of both sides. Yes, we can take the log of both sides and we will solve and we get the same answer. But in maths, we like to be a little bit, colorful. So what we like to do is to take a special log, okay? That special log is log to the base e. Okay, so that is what we will do. And then we will also have log to the base e here. Then we have 3. So now this is how it's going to look like. All right, so maybe you've taken log to the base 5 to the base 10 to the base 1 billion, but in this case we are talking about to the base e. Well, e is also a number, it's not a letter, okay? E is 2.7 blah 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 blah. It goes on. You can just put it on your calculator and see the value of e. It's a non-terminating decimal. It works like pi, so it never ends. Okay, so this special notion that, well, we can take the log to the base e, what maths we wanted to make it look really nice, so we said, well, log to the base e is what we will call the ln, okay, the ln. So instead of we saying that, well, take the log to the base e of both sides, we can say just take the ln of both sides. So if you have e to the power x equals 3, then we are going to have ln e to the power x is equal to ln 3. You see, now this is much cleaner, okay? And that is what maths seeks to do. But the thing I want you to take from this graph is that the exponential function, all right, has an inverse, and its inverse is the ln. And then the natural log also has an inverse, and its inverse is the exponential function. So they are just reflections of themselves in the line y equals x. So that is what I want you to take from here. Now, based on what we've gathered so far, let's jump right into applying this knowledge to solving problems. But before we do, all the laws of logs that you know, okay, all the laws of logarithm, all those laws apply to the natural log because it is also a log, okay? So keep that in mind. So let's apply all that we've learned to this particular question. But before we do, I need you to take notes of some rules, okay? Rule number 1. As we go on, I'll be telling you more rules. E to the power ln x is equal to x, okay? Right, take note of this. E to the power any value, okay, e to the power ln any value, the answer is that value over there. All right, so now we want to solve for x in this particular problem. So that means that from our left-hand side, everything here collapses to x. So we can just say that x is equal to 7, okay? Easy like that. So that's the rule. Now, if we have a case like this, what is the next rule? So rule number 2, if we have ln to the power e to the, let's say y, okay, the answer is just y. All right, they are just let me highlight this. This is the same as what is there. You know, consider these two examples. This rule states that e to the power ln x, the answer is the x there. But if you flip it the other way around, where you have ln e to the power y, the answer is y. Let's actually prove this rule for you. We have already argued that ln is e base what? Log e base, sorry, log to the base e. So we have this guy here. Now, since it applies, the laws of log applies to the natural log, this y will come down here. So we have y log e base e, and that is y. So that is the main reason why this rule is also true. So check it out. It's very correct. Put that in mind. So that means that whatever we have here, the answer is just x. Okay. So we have x is equal to 2.5. Okay. How about this one? Well, don't be quick to say that, well, then x is equal to 37. You are wrong, because there's a 2 here. Okay. So that 2, remember, this is the rule. Now, the rule I showed you, there's nothing multiplying the y apart from 1. So be careful. And if you look at this rule 2, there's nothing multiplying ln x apart from 1 here. So be careful. Now, we are going to get e ln x squared, okay? Let the 2 come back, is equal to 36. Then you can say that e to the power ln something is that answer. So x squared is the answer on the left hand side. It's equal to 36, giving you x is 6. Okay. I know you want to put plus or minus 6, but the ln of a negative value does not exist. That is why I didn't take the plus or minus. Anyways, why am I saying that the ln of a negative value does not exist? Check this now. When you consider the graph of a ln, it's actually from this it is asymptotic to the 0 line, okay? It never touches this line, and it's on the positive side, okay? So it never comes somewhere here, so it will never take a negative x value. It's always on the positive side of the x-axis. All right, let's continue. How about this problem? Well, you know what? Let this negative come back. So you are going to have e to the power ln x negative 1 is equal to 20, giving you x to the power negative 1 is equal to 20. Remember, indices 1 over x is equal to 20. Therefore, x is actually 1 over 20, right? Okay. Now, how about this case? How do you solve it? E to the power x is equal to 7. Well, you see, whenever you have e to the power something, it is easier if you just take the log of both sides, right? Yeah. Even if, let's say this were to be 2 to the power x equals 7, you would just take the log of both sides, right? Okay. The same thinking is what we do here. But right now, instead of taking the log of both sides, what we take is the ln of both sides, because it is e. E, we use ln in math. I mean, fancy. But it doesn't, if you like, you know what, let's explore something. All right, for you to just see that it is just for the sake of fancy stuff. That's why we keep the ln. So first, let's take ln of both sides. Okay, so this will be x, okay, is equal to 7. Oh, sorry. We are taking ln of both sides, but I didn't take ln of the 7. So ln 7. So x is equal to ln 7, okay? And if you like, you can just put it ln 7 on the calculator. Let's see. Let's just get it in 3 significant figures. Ln 7 is 1.95, okay? Now, what if from here you just decide to take the log of both sides? Okay? log 7. So you are going to have x is equal to log 7 over log e, right? So let's see, what would that be? Log 7 over log, so log 7 over log e. Good. The calculator tells you that x is 1.953 SF. So the point that I was trying to make earlier is that we mathematicians choose to go with len because it makes the work cleaner. Okay, so we say whenever we see the e, we are going to use len instead of log. Okay, so it's not like technically you are wrong, no, because you get the same result, just that it's a beautiful way to present your solution. All right, how about this particular question? How do we solve it? The G. Well, first, make sure that you make e to the power x the subject, okay? So we have 2 here. Let me use black. 2 e to the power x is equal to 7 minus 1. So we have 2 to the power e x is equal to 6. So e to the power x is equal to 3, okay? Then I can take the len of both sides, giving me len e to the power x is equal to len 3. So x is basically len 3. Now, when the question says leave your answer in the exact form, leave it this way. Unless the question says that leave your answer to 3 SF, then you put it on calculator and then you round it. So from here going, I wouldn't be putting my answer on the calculator. I'm just going to leave it in the exact form, okay? How about if you have the h? How do you approach this particular problem? Well, you can just straight away take the len of both sides, which is going to give you len e 2x minus 5 is equal to len 3. Then you will have 2x minus 5 is equal to len 3. So 2x is equal to len 3 plus 5. So x is len 3 plus 5 all over 2, okay? And you are done. Easy like that. How about this particular one? So in this case, you have len x cubed plus len x equals 5. Well, remember that in len itself is a log. So all the laws apply. They are adding, right? So when they are adding, think of multiplication. So if I pull len out, I'm going to get len x to the power 4 is equal to 5. Okay? Then you can take, since you want to find x, okay, if you have len and you want to find x, what you do is that you make e the base for all the argument. So this will be e len for x to the power 4 is equal to e to the power 5, okay? So the argument that you had here, all right, you let e come to carry all of them. Why? Well, to answer your why, let's go back to rule number 1. Now, rule number 1 says that when we have the e to the power len anything, the answer is that thing. That is why we can do what we are doing. So our answer is going to be 4 to the power x to the power 4 is equal to e to the power 5, okay? Now from here, we want to find what x. So you can just say that, well, I will take the 4th root. So you can just write x is equal to the 4th root, okay, of e to the power 5. And you can leave your answer like that. That is if they said give your answer in the exact form. If not, then put it on a calculator and then write the value there. How about the J? Okay, so for this particular problem, what we have is, it's easier to take the len of both sides, right? Let's see how that would help. So I have len e to the power 3x plus 4 is equal to len 2 e to the power x minus 1. Okay, now the left hand side, we're just giving 3x. plus 4. The right hand side, though, be careful. You know, if you have something like this, the 2 is definitely multiplying this particular function. So I think it would be best if I put it in a bracket so that you see what is really happening. So once I want to remove the bracket, I apply the multiplication rule. So I have ln 2 plus ln e to the power x minus 1. Okay, so this will give us 3x plus 4 ln 2 plus x minus 1. Okay, then you group all the x, so you have 3x minus x is equal to ln 2 minus 1 minus 4. So you're going to have 2x is equal to ln 2 minus 5, okay, and then x is equal to ln 2 minus 5 all over 2. So you can leave your answer in this form if the question says leave your answer in the exact form. If not, then you'll be forced to put it on a calculator and then you round it to 3 significant figures. All right, now let's see, is this our last question? Nope. All right, so now we have this particular one. Well, from the onset, whenever you see x and then you see 2x, think of a quadratic. I want you to start thinking of quadratic, okay? All right, so the first thing that you want to do is to, okay, so when you solve it to a particular level, you will just see that it's a quadratic and can just do the variable substitution straight away. If not, then I want you to write this as e to the power x, all right, all square. Okay, this particular case gives you this. Then you can write minus 9 to the power, e to the power x plus 20 is equal to 0. Then you can do the variable substitution by saying that probably let y be equal to e to the power x. All right, from there you can have y squared minus 9y plus 20 is equal to 0. Now you see why I said think of the function being a quadratic? Yes, because it's way easier that way. I mean, okay. Excuse me. Now, whenever you have a quadratic like this, I believe that at this stage we can all solve such a quadratic. All right, so we are looking for factors of 20. When added, will give us -9. So that's obviously -4 and -5. So you have y minus 5 and y minus 4 is equal to 0. So y is equal to 5 or y is equal to 4. But, you know, we brought a y, so you just have to bring but e to the power x is y. Now take the first case, okay? That is e to the power x is equal to 5. All right, and then or we have e to the power x is equal to 4. Okay, so let's start with the first case. If we have e to the power x is equal to 5, we can just take the ln of both sides. All right, ln 5. So this is going to give us x is equal to ln 5. I'm not going to put it on calculator, I'll just leave it like this. Or then we have e to the power x is equal to 4. So we would take the ln of both sides again. So x is equal to ln 4. All right, that's how we end it. Okay, how about this particular one? Well, don't be quick, okay, to do the substitution now. Hold on, apply a little bit of indices. Indices says e to the power x plus 2 over e to the power x is equal to 80. Now you can do the substitution. You can say that let w be equal to e to the power x. So that means that we have w plus 2 over w is equal to 80, right? So we can have w squared plus 2 is equal to 80w. So we can have w squared minus 80w plus 2 is equal to 0. Well, this particular quadratic is not easy to solve because having factors of factors of 2 giving us the -80 is just crazy. So what you want to do is to use the quadratic formula to solve this particular one. All right, so w is equal to -80 plus or minus the root of -80 square minus 4 into 1 into 2 all over 2 into 1. Okay, now when you simplify, calculator will tell you that there are two answers. So the first answer would be, let me just put it on a calculator and see. Okay, so we have 79.97. So 3SF is basically 80. Okay. Then we have another W to be 0.025. Okay. 0. All right. So that's it. Basically, that's it. All right. Now, how about this particular one? I think is the last one we are solving for today. So in this particular problem, what I want you to do is to divide both sides by 5, because when you do that, len stands alone, and when len stands alone, it is a good thing. Okay, so we have len 7 minus e to the power 2x is equal to 3 over 5. Okay, now I want you to take e, all right, let e become the base, carry everything there. So you are going to have e here, you are going to have e there. All right, so you have len 7 minus this 2x equals 3 over 5. Okay, now you remember the rule, so this will be this guy 2x is equal to e to the power this 5. Okay, so we have 7 minus e to the power 3 over 5 is equal to e to the power 2x. What we want x, so now what you want to do is to take the len of both sides. So let me just flip it and write it this way. It's easier that way. I like to write the letters on my left. Okay, so I'm going to have len e to the power 2x is equal to len 7 minus e to the power 3 over 5. Therefore, I'm going to have 2x is equal to len 7 minus e to the power 3 over 5. And now I can just divide 3 by 2. So x is equal to len 7 minus e to the power 3 over 5 all over 2. Okay, and then we are done. So this is how to solve this particular problem. Let me zoom a little bit out so that you can see how the whole thing is done. So the first thing is that we decided that we are going to just divide by 5. We did that, and then we brought e to help us simplify this together. And then from there, we decided that since we want x, we can, and there's an exponential, just take the len of both sides, and this is what we got. So this is where we are ending in today's video. The next one will be on the practical application of exponential functions. All right, so this is, a sample question that they will ask. They'll give you a story, and then based on that story, they start to ask you questions about it. You are just applying everything you've learned in exponential functions to the problem. They are not really difficult at all. So watch out for this video on my channel in the next few hours. Right, till we meet again. Bye.